Welcome to another Mathfolio video. This time the video is on a Regents review. This is the Geometry Common Core Regents review, and this is the June 2015. To download some of the resources today, you can visit mathfolio.com/geocc June 2015 QUS. That's for the actual exam. You can visit the second link that ends in ANS for the answers to get all of the answers. And the third link is to view sample responses, where you get to see student work and the number of points they received for each of their responses, which is really useful to see why students lost marks as well. Question 1 from this test is talking about taking a two-dimensional shape, this right triangle, and spinning it around. So the actual part that it's talking about rotating is this here. So if you imagine this thing actually being turned around this whole shape this way, then it's saying what shape will you get. So this is just something you've got to think about. And if you think about this being turned and rotated, what shape would you get? Well, you would get if you imagine it, you would end up with a cone as this thing turns. So number 4 is your answer, and the easiest way to think about it is actually turning something really, really fast and imagining the three-dimensional solid shape you would get. So that's question number 1. Okay, question number 2. Says the vertices of triangle JKL have these coordinates, and it says under which transformation is the image of J prime, K prime, L prime not congruent. So it's saying that you start off with a triangle and the coordinates themselves are not really all that important, but you start with a triangle and you end up with a triangle that is not congruent. So what would make this triangle not congruent? So it would probably be something that is either bigger, or maybe the shape itself shrinks and becomes smaller. So this would be a dilation. So dilation is the only transformation that results in shapes that are not congruent, because a dilation is not what we call a rigid motion. And rigid motions preserve distance. So dilations change the shape and it makes them not congruent. However, they could be similar. That was question number 2. Okay, so this is question number 3. In this question we're told the center of a circle Q has coordinates of 3, -2. So let's take a look at what this means. If we've got an X and a Y axis, and Y, and if we've got a circle that is plotted here, the center is going to be at 3 and then -2, so it could be the center. And if circle Q passes through 7, 1, so let's take a look at what that means. 7 might be all the way out here and 1 is here. So basically a circle passes through this point. Now, it's going to be a little tricky to draw, but this is basically saying that if you've got a circle with that center at 3, -2, and it passes through the point 7, 1, then the circle will look something like this. Now, one of the things that we've really got to remember is that this here, that distance, is the radius. Now in this question we are asked for what is the length of the diameter. So if we are able to find the radius, then we can remember that the diameter is 2 times radius. So in this situation, the best thing that we can do is just do the distance formula between 3, -2, which is the center of the circle, and this point on the outside, which is 7, 1, and that number we were also given here as well. That was point R. So we're really trying to find the distance QR. So to do this, QR equals, now this is the distance formula. So it's x2 minus x1 all squared plus y2 minus y1 all squared. Now if that's a little tricky to remember and to plug in, there's another option that we've got, which is to consider this right triangle that lives here and then just do the Pythagorean theorem. Now that's pretty much what this equation is doing anyway for the distance, but here you need to see that we jump from 3 all the way to 7. So that's a jump of 4, which is this distance for the leg, that's 4. And then also we jump from -2 all the way up to 1. So that's a jump of 3, and so that's this side. So this triangle becomes this, 3, 4, and then you can do Pythagorean theorem to find the distance, which is the radius. Now this actually happens to be a 3, 4, 5 triangle, so it's a Pythagorean triple, but we could also do it and find out that r is 5 by just doing the Pythagorean theorem. 3 squared plus 4 squared equals r squared. So that's 9 plus 16 equals r squared. So 25 equals r squared. So when we square root both, we end up with r equals 5. And don't forget, the diameter is 2 times the radius. So that is 2 times the 5, which equals 10. And so we just found out that the length of the diameter is 10. But if you did want to plug in here, then this could be your first x1, and then this could be a second x, so we call it x2, second y, and then first y. So this would become the square root of 7 minus 3 squared. So that gives us the 4 squared that we have all the way over here. And then plus y2, which is 1, minus y1, which is -2, and squared. So when you minus a negative, these two become plus. So this becomes 3 squared, which is the same as this number right here. So again, it becomes 16 plus 9, all square root. So in the end, QR, which is the radius, is radical 25, which is 5. And we must double it again. And the reason being, because if we double it, we get the distance from one side all the way to the other, which is the diameter. So either way, our answer is 10. So that would be option number 3. Okay, question number 4. It says in the diagram below, congruent figures 1, 2, and 3 are drawn. 1, 2, and 3. And just checking, it looks like they each have 6 sides, and so these are all hexagons. It says which sequence of transformations maps figure 1 onto figure 2. So 1 onto 2, and then 2 onto figure 3. So mapping is just kind of moving it onto that shape. That's how we can think about mapping. So for 1 to go on top of 2, now to check that the orientation is the same, we want the letters to be in the same order. And as you see, A starts at the top and then it goes clockwise, B, C, D, E, F. And that's kind of the same as what happens here, except they're called primes because it is the image of the pre-image. So because the orientation is preserved, it looks like to go to this image, we move it over and we move it up. It looks like it's a translation first. Looks like it's translation. Then if I change color, the next thing that looks like it happens is it doesn't look like another translation because it looks like the shape is turned. And as you see, the A, instead of pointing up, is now pointing to the right. And the E and F, instead of being on the left, they're now on the top. So it looks like if this was the center, it looks like this shape has rotated around. And so it looks like the second transformation is a rotation. And so it says a reflection followed by a translation. Well, that's not what happened. A rotation followed by a translation. Nope. A translation followed by a reflection. Well, we did translate, but we didn't reflect. We didn't flip it. So our answer is a translation followed by a rotation. Option 4 is our answer. Okay, question number 5. Okay, as shown in the diagram below, the angle of elevation between a point on the ground and the top of the tree is 34. It says if the point is 20 feet from the base of the tree, what is the height of the tree? So let's call the height of the tree x, and this is the point on the ground that it talks about, and it says that this is 20 feet. So if it helps, you could draw a separate triangle, knowing that this is a right triangle. You're given that this angle is 34. You know that the base of the triangle is 20 feet. And so what we're really dealing with is we have an opposite and we have the adjacent. So this isn't the Pythagorean theorem. This is in fact SOHCAHTOA. So we have the opposite, we have the adjacent. So it always helps to write this out. SOHCAHTOA. So with the opposite and the adjacent, we're dealing with tan. And so we can say that tan of the angle, 34, equals the opposite, which is x, all over the adjacent, which is 20. And so when we times both sides by 20, they cancel over here. And we've got that x equals 20 tan 34. And so that's going to be our answer. So we just need to punch this into the calculator. Now, one thing that I definitely advise that everybody do is when it uses italic in part of the question, circle this, highlight it, do something, because the answer that I get on the calculator is 13.49017034, and it goes on and on and on. But in this case, we don't want all of that. We want to round it to the nearest tenth, and so our answer is 13.5. That's our answer. So that would be option 3. Okay, question number 6. Okay, in this question it says, which figure can have the same cross-section as a sphere? Well, a sphere is a 3D ball shape, and so often when I draw it, I kind of put these shadows on it. Now, if we cut this shape with a straight line, we cut it straight through, the only cross-section that we can see when we cut this is going to be a circle. So if you imagine the section that I cut out of this, when you slice it and take a look in there, it's going to be a circle. So from this shape we can't get a circle, from this one we can't, from this one we can't, but we can get a circle from a cone if we cut it directly across this way. That's where we're going to see another circle. And so this is the same cross section as from the sphere above. So number 2 is the option, is the answer for question number 6. Okay, question number 7. A shipping container in the shape of a right rectangular prism. So stop. This is where really big word problems can cause you a lot of problem unless you take a time out and draw or label a diagram. So we've got a right rectangular prism, and so I'm going to draw that by showing a rectangle at its side here, and then I'm going to draw exactly the same shape over here, rectangle over here, and then the trick is just to join up all of these sides. So I'm just connecting them like this. So this could be a shipping container. Now it says that it has a length of 12. So let me just change color for a second. It has a length of 12 feet, a width of 8.5 feet, and a height of 4 feet. it says the container is completely filled with contents that weigh on average 0.25 pounds per cubic feet. So let's write that. So this is where it's really important. On average, 0.25 pounds per cubic feet. So the weight, 0.25 pounds per cubic feet, which we can write like this. So it says the question, what is the weight in pounds of the contents of the container? So cubic feet is the volume. So if we can find out the volume of this entire container, they told us it's full. So when we find the total volume, we can just multiply that by the 0.25. So the volume of a rectangular prism is length times width times height. So it's going to be 8.5 times 4 times 12. So when I plug all of those numbers in, 8.5 times 4 times 12, I get an answer of 408. So 408. Now, as you look at the answers, 408 is there, so that's going to really catch some people out. But we don't want to circle that answer. We want to take this volume, and because it's 0.25 pounds per cubic feet, we need to multiply these two numbers. And so when we times this by 0.25, which is the same as timesing by 1/4, we're going to get 102. So times by 0.25, we get 102. So I'm just going to write that in down the bottom. We get 102, and this is going to be our answer, the weight in pounds. Question number 8 says, in diagram of circle A shown below, chords CD and EF intersect at G. So that's shown right here. C to D and E to F intersect at G. And it also tells us that C to E and F to D are drawn. Which statement is not always true? So this is really important. Not always true. Well, let's label what we know. As you can see, angle C right here is an inscribed angle, and it comes from points E and points D. Now, because F is also inscribed coming from those same points, we know that angle ECG and also angle EFD are both congruent. Now, we also know this angle here at G, which is CGE, is congruent to angle DGF because they are vertical angles. And because we've got two angles the same, the third angle must also be the same. So I'm going to put 3 lines here. Two angles are the same must mean that 3 of them are exactly the same as well. And so I'm going to label both of those. So because all 3 angles are the same, we know that these two triangles are in fact similar. So we can say that this triangle here, which we can call C to E to G, is similar to the other one, which is over here, which is F to D to G. So we know that to be true. So let's take a look at some of these. The first thing says that CG is congruent to FG. Now, that's going between the 1 arc and the 2 arcs, and this is the 1 arc and the 2 arcs. Now, they could sometimes be congruent, but because these triangles are not necessarily congruent, the only thing that we know is that they're similar. These two do not have to be congruent, and so it looks like number 1 is our answer. Now we can check a few of the others. Number 2 says CEG, C to E to G, which is this angle right here with the dot, is congruent to FDG, F to D to G, and that's this one here. Well, we've already put the 3 lines, the 3 arcs, and so we know this to always be true. Number 3 says that C to E, which is CE, which is right here. Let's do this with a little dashed purple pink line, this side right here, all over EG, where is it? CE to EG. So that's the two sides here as a ratio is equal to FD. So let me change this color, pick an orange, is equal to FD, which is the outside piece here. Notice it's going from the 1 arc to the 3 arcs, just like this one went from the 1 arc to the 3 arcs. FD all over DG. So these two sides are proportional because they are this over this. Does it equal FD right here all over DG? And it does, because they are proportional. And then the last one, triangle CEG. CEG is similar to FDG, and that's also true. So the answer, as we thought, was option number 1. Okay, question 9. Okay, which equation represents a line that is perpendicular? So that's very important, that word right there. Perpendicular, and that's the symbol, to the line represented by this. Well, if it said parallel lines, then we know something about the slope. It's the same slope. If it said perpendicular lines, we know it has the negative reciprocal slope. So first thing to do is figure out what is the slope of this. Well, we can write it in a little better way. If we've got 2x minus y equals 7, if we minus the 2x from both sides, now we've got to be very careful here, because we're going to be left with a negative y equals, now I'm going to make sure that the x's stay at the front so that we can make it look like y equals mx plus b. So that becomes negative 2x plus 7. Now to get positive y, we have to divide, or in fact multiply by negative 1. That would work. And so in this case, we get y equals 2x minus 7. So if I just change the pen color over, we end up with a slope that is 2. And the y-intercept is negative 7, but that's not such a big deal. So if the slope is 2, we don't want the same slope being parallel, because it's not parallel, in fact it's perpendicular. So anything with a slope of 2 we can get rid of. So it's definitely not number 4. But what we do want is we want to do the negative reciprocal of this. So that becomes 1 over 2 when we do the reciprocal. We just turn it upside down, and it's currently 2 over 1, so it turns upside down, and then it gets negated. So if it's already positive, it becomes negative. So when we look up here, the only one with a slope that is negative 1/2 is option 1, and so that's our answer. Okay, question number 10. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So let's think about what this means. Now, if I just take a shape like, let's just say a pentagon, and it's saying a regular shape, meaning that all sides are the same. So right now, I'm not saying that this is the answer. I'm just pondering, I'm just thinking about what it means to rotate it onto itself. So here's the center. Now, if we turn this, let's just label these vertices. It might help us. A, B, C, D, E. Okay, so if we rotate this 360 degrees, it means that A would end up back on top of A. So this would be a 360 degree turn. But there's also a way to rotate it where it looks exactly the same, but by not doing 360. Because this is a regular polygon, we can move it where A would go on top of B. And the reason why this all works out is because if you draw lines from the center to each vertex, then you can see that if this line becomes this line, the shape looks the same. and then B would move to C, and C would move to D, and so on. This would all happen with a fraction of a turn of the 360. So because there are 5 vertices here, in the case of a pentagon, all we would need to do is to turn it 360 divided by 5. And if we turned it that much, 360 divided by 5 gives us 72 degrees. So in the case of a pentagon, it would need to turn 72 degrees to go back onto itself. But we're not talking about 72 degrees. It's asking us which regular polygon has a minimum rotation of 45 degrees to carry it onto itself. So one thing we can do is we can think about how many sides each of these shapes have. Well, an octagon has 8, a decagon has 10, a hexagon has 6, and a pentagon has 5. Well, we've already discovered with a pentagon it needs a 72 degree turn, so it's not going to be that answer. For a hexagon, if we do 360 divided by the 6 vertices, that gets us a minimum turn of 60 degrees, so that's not going to help us out. For a decagon, that's going to need 360 divided by 10, which is 36 degree turn, so that's not going to help us. So it must be the octagon, but let's check. If we take 360 and divide it by 8, that does in fact give us our answer of 45 degrees. So therefore the answer is definitely octagon, and all that needs is a 45 degree turn and the shape looks like the original shape, even though the equivalent A has moved on to B and B on to C and so forth. Okay, question number 11. In this question we've got a triangle and a triangle, which often means that they're similar triangles. So it says in the diagram below, ADC, triangle ADC below. In the diagram of triangle ADC below, segment EB is parallel to segment DC. So I'm going to label that. This is parallel to this. So that tells us a whole bunch of things. It tells us that segment AC is a type of transversal. And so because they are corresponding, this angle matches with this angle, and it also tells us this angle matches with this one. And it's hard to see, but AEB, that smaller triangle, and ADC both share this top angle. So I'm going to label it with 3 arcs. Now what also might be useful is if I draw this shape over here. So I'm just going to separate these 2 triangles. So this can be the first triangle, the smaller one, and then this can be the much taller one. Now, because 3 angles are congruent in each of these shapes, we actually know something else. We know that these shapes are in fact similar. So, and they're similar by the postular angle-angle. And angle-angle tells us that 2 angles inside the triangle are congruent, and so the third one must be congruent, and so the 2 triangles themselves are similar. So I'm going to label all the dimensions on these 2 triangles. This is 9.2. Over here, the full distance from A to D is 14, because that's the sum of the 9 and the 5. So that's the 14. So the question says, what is the length of AC? So AC is right here. I'm going to call it X, and it wants to find X to the nearest 10th. So because these are similar triangles, we can make a proportion involving corresponding sides. So we've got the 9 over the 14, those 2 are corresponding, is equal to the 9.2 all over the X. Now we can solve this by cross multiplying, so we've got 9x when we cross multiply here equals 14 times by 9.2, and then to get x on its own we would divide both sides by 9. So x equals the result of this. So grab a calculator, and it's 14 times 9.2. And then divide that by 9. And I get an answer of 14.31 recurring. So it does say find the answer to the nearest tenth. So instead of putting 14.3 and then 11111 to the nearest tenth, chops all of that stuff out, and our answer is 14.3. Okay, question number 12. Okay, in scalene triangle ABC shown below in the diagram, the measure of angle C is 90. So we've got C right here, and that's labeled as 90 with the little square. It says which equation is always true? And then we have a few options involving sin, cos, and tan. So these are the trig ratios. So ca, toa. So in order to prove this, prove which one is correct, let's label the sides. Well, opposite angle A is side little a, opposite angle C is sine little c, and opposite angle B is little b. And so for number 1, it says sine A equals sine B. So let's think, sine A equals sine B. Well, sine of A is, so we're dealing with sine, is the opposite, which is A, all over the hypotenuse, which is C. So that's A over C. Sine B is opposite, which is B, all over hypotenuse, which is A. So that's B all over A. So do those two look the same? Well, they're not the same unless A over C is the same as B over A. So that would mean that both B and C would have to be the same length for that to be true. And that's not going to happen because C is the hypotenuse and it has to be the bigger side. So that's not going to be true. So this is not the case. So 1 is not the answer. For number 3, let's check that one next. It says cos A equals sine C. So I'm going to change the color of the pen just while I label the diagram. So the cos of A, so cos is the adjacent and the hypotenuse. So the adjacent is B all over the hypotenuse, which is C. So B all over C equals sine C. So C is here, sine is opposite over hypotenuse. That's C over C. And that's a little weird, so it's not the case, that's not true. So we can cross out number 3 as well. So let's try number 2, cos of A. So A is here, cos is the adjacent, which is B, all over the hypotenuse, which is C again. So B over C equals, now the cos B is adjacent, which is A, all over hypotenuse, which is C. So A all over C. And that's not going to be true unless A and B are the same, which would make this an isosceles right triangle. And that isn't always the case, and that's what we're looking for. So it's definitely not 2. So we've already cancelled the first 3. It must be 4, but let's prove it. I'm going to choose a pink color. So it says sine of A. So sine is the opposite, which is little a, all over the hypotenuse, which is little c. So A over C equals, and then cos of B. So B is here. So cos is adjacent all over hypotenuse. So A over C equals A over C. That is correct. And so 4 is our answer. Okay, question 13. Quadrilateral ABCD has diagonals AC and BD. So AC and BD. And it says which information is not sufficient to prove ABCD is a parallelogram. So let's draw a parallelogram because that's the shape that's mentioned. and we're told that AC and BD are the diagonals. So AC and BD are the diagonals. And it says which information is not sufficient to prove that it's a parallelogram. So AC and BD bisect each other. AC and BD bisect each other. Well, let's think, is that the case for any other shape that is not a parallelogram, that they bisect each other? Let's think, well, even in a kite, even in this shape of kite, the diagonals are perpendicular. This is bisected, but this is not bisected here. So maybe that's a good start. Let's leave a question mark for that one. Okay, for option 2, it says AB is congruent to CD. So A to B is congruent to CD. And also BC is congruent to AD. Alright, well that's also a good start, right? Maybe that has to be, because even if this is really, I should put an extra one here because it's only saying opposite sides are congruent. Even if this was a square, which this information proves, or allows for at least, or if it was a rectangle, or if it was a rhombus, all of these shapes are types of parallelogram as well. So it looks like this one is okay as well. So these first two are looking promising, as though they do prove it's a parallelogram. Let's keep looking though. Number 3, I'm going to change the color up. Number 3 says AB and is congruent to CD. So AB and CD. So let's do this in green. AB and CD. And then also AB is parallel to CD. So this is parallel to this. So if those two are parallel, it means this distance between the two parallels must also be congruent, because they never intersect. So this must be the same as this. So that's now telling us the same as the second one. So that one seems like it also must be one of these shapes, which are all types of parallelogram in the end. So therefore it's looking like that one's okay. So let's check the last one, number 4. Change the color. It's saying, so I'm going to redo the parallelogram here. It's saying if AB is congruent to CD, and then also that BC is parallel to AD. Well, let's think about this. If these two are parallel, then that defaultly means that this distance must be the same. So you've already know that distance is the same, but do we know that this distance here, do we know if this distance is the same as this distance? That's the big question. So let's imagine that same description for 4, where this is parallel. So that would be like your AD. Let's put some vertices on the end. Now let's say that BC is here. BC. Now that's this piece of information here, that BC and AD are parallel. Now the other bit of information, let me just go to green for a second. The other bit of information is that segment AB is congruent, A to B is congruent as C to D. So in this case, number 4, I've managed to make a trapezoid, an isosceles trapezoid, out of the same information. So therefore, this shape is not a parallelogram, because we do not have 2 parallel pairs of sides. So therefore, 4 is not enough, not sufficient to prove that ABCD is a parallelogram. Okay, number 14. The equation of a circle is this, What are the coordinates of the center and the length of the radius of the circle? All right, so this is a little tricky because usually we are used to seeing the equation of a circle looking like this. Now here they've given us a 7 equals, and then x squared plus y squared plus 6y, and that's it. And there's no x's on the row, just x squareds. So if we can find a way to make this look like this, then we'll be able to say, oh, this is the radius and this is the x and the y value of the center. But we've got to try and make this look like that. So we can start off in a few ways. We can think of this as, this is x minus something squared. Now, although this y squared also has a y value with it, the x squared doesn't have a coefficient with an x. So therefore, it kind of makes me think that's got to be 0. And then if we imagine distributing this by foiling it, it would just really be x squared, because x minus 0 is just x, and then x squared gives us that x squared. So everything that I've got right here will give us this guy. But now we need to get this thing from a binomial in these parentheses, binomial meaning 2 terms in there. So we've got to think, well, what could this be? Well, if we do y and then plus 3 and then square it, let's see why I did plus 3, because over here, let's just FOIL this out. So y plus 3 times y plus 3, that's really what I've got in this parentheses over here. Got y plus 3 times itself. So y plus 3 times y plus 3. So if I FOIL this out, I've got y times y, which is y squared, y times plus 3, which is plus 3y. I've got 3 times y, which is another plus 3y. Now together, that gives us a 6y, which we have over here. But we have this additional plus 3 times 3, which is 9. So when we FOIL this whole thing out, we've got y squared plus 6y plus 9. So this was looking good, but what it pretty much did, this parentheses, it added an extra 9 to the right-hand side of this equation. And don't forget, this is an equation with things on both sides. So if I've added 9 inside here by rewriting this as y plus 3 squared, I have to add 9 to the other side. So this whole thing becomes 16 equals x minus 0 squared, which I could just write as x squared, plus y plus 3 squared. Now looking at this, this looks very much like our equation of a circle up at the top. And this is really, really great for us, because this 16 can be written as 4 squared. So I know my radius is 4. The h, comma k, which is the center, is this 0, which, as it says minus h, and it says minus 0 here, that means that h is 0. And because it says minus k up there and this says plus 3, that's the same as doing minus negative 3. So my k is in fact negative 3. So these are the 3 bits of information, the radius, and then the x and the y value, the radius and the center, exactly what we need. So the radius is 4, so I can get rid of this one and this one because they have a radius of 16. And then for the center, 0, negative 3, our answer must be option 2. And so we just showed how to solve this problem by making the equation they gave us look like the generic equation of a circle. That was question 14. Okay, number 15 gives us two triangles, ABC and DEF. It says AB is 9, so I'm just going to start labeling. Label my 9. Here goes. So this is 9. I've got a BC is 15. Got DE is 6. D to E is 6. E to F is 10. And I know that angle B and angle E are congruent. So B and E are congruent. It says which statement is true. Alright, well let's think about this. It says that a couple of angles are congruent here. So we've got to think about that. Option 2, it says that AB, A to B over C to B is equal to FE over DE. Then here we have another proportion, and here option 3 says that the triangles are similar. So let's compare this. We've got a side angle and a side labeled, a side angle and a side labeled. So I know SAS is one of the postulates for congruency, but these triangles have different side lengths, so they can't be congruent, but perhaps they can be similar by side angle side. And for this to be true, they would need the angle between two sides to be congruent. Now we know that to be the case because we were told it, B and E are congruent. But the sides themselves would need to be in the same ratio. So we need to compare, let me highlight them, we need to compare 9, which is right here, and which is the smaller of the two, to the 6, and we need to compare the 15 to the 10 and see if that ratio holds. So 9 compares with 6, and we're testing this equation as 15 compares with 10. So we want to make sure that this is in fact true, and if it is true, then we know that these two triangles are similar by side angle side. So 9 over 6, well, 3 goes into 9 3 times, 3 into 6 twice. Now 5 goes into 15 3 times, 5 goes into 10 twice. So we've got both of these fractions are the same, so therefore these two triangles are congruent, forgive me, not congruent, but these two triangles are similar because the sides are in the same ratio. So let's check each of these one by one, now that we know that these two shapes are similar. So option 1 says C to A to B, CAB, which is right here, we put dotted line because we're checking it, is congruent to DEF. D to E to F, what's here? Well, we know that matching angles, corresponding angles are the same, but here angle B matches with E, and those two are congruent, so the other two do not have to be the same. So it's not option 1. Next. Now we know that AB, which is the 9, does match with ED. Okay, so let's think about this. AB, which is right here, and they're dividing this side by CB, which is the longest that we've got labeled anyway. So you've got the 9 to the 15 compares to FE, which is the longer one, over the shorter one. Well, that wouldn't be true because here AB over CB, AB is 9 over CB, so that's like 9 over 10, and they're saying that equals, not 9 over 10, 9 over 15, and they're saying that equals FE, which is 10, all over DE, which is 6. Well, this number here, 9 over 15, is less than 1, and this is more than 1, so they're not equal. Can't be option 2. Now, number 3 says triangle ABC, so that's A to B to C, so that's, we've got to be careful of the journey. It has to be the same journey, so it's the shorter to the angle to the longer. is similar to DEF, D to E to F, so that's going through the shorter and then to the angle to the longer. So it looks like this is true. It looks like it's true because AB does in fact correspond with DE, and also CB or BC does in fact correspond with EF. So that's going to be our answer. Let's just prove that option 4 is not correct as well. So I'm going to change this to a green pen. So it says AB, which is right here. I'm going to do a zigzag, over DE, which is right here. Now, those two are corresponding sides, but then it says equals FE all over CB. Now, although they are corresponding, notice that in this first one, AB to DE goes from the triangle on the left to the triangle on the right. So this is the left and this is the right. But FE is on the right, and then it goes to CB, which is on the left. So this one, they got it upside down, so it's not 4. So our answer to 15 is option 3. So question number 16 says if triangle ABC is dilated by a scale factor of 3, which statement is true of the image of triangle A prime, B prime, C prime? So if you've got a triangle, and let's say this is 1, 1, and this coordinate over here was 3, 1, and this coordinate here was 2, 4. And you dilated this with a scale factor of 3, we can imagine that this shape changes quite a lot. It's going to grow by 3 times. So this point here is going to be 3, 3, because we multiply both of these coordinates by 3. Do the same here, so this is going to be 9, 3. And this here is going to be 6, 12, if I've multiplied that correctly. So a distance between these 2 points is from 1 on the x to 3, so that's a distance of 2. And the distance here from 3 to 9 is now a distance of 6. So you can see that the distance itself has also grown by a factor of 3. So it says, which statement is true about the image? So A to B, which let's say this is A to B, and this is A prime to B prime. So the first one is 3 times A prime B prime equals AB. Well, that's not the case. A prime B prime is much bigger and AB is much smaller, so this is not going to be the right answer because you're timesing the bigger number by 3. So that 3 really should be next to this. Okay, the next one, B prime C prime. So let's think about this. C prime is up here. B prime C prime is 3 times B times C, which I'm pretty sure that's it. That's just what we were saying, is that you take the smaller side, BC, before the dilation, multiply it by 3, and that gives you the new shape. So this is going to be our answer. Now let's just look at the other two. This is looking at angles. So it's saying the angle of 1 multiplied by 3 is a new angle. And these two aren't the case, and let me explain why. In both of these shapes, angle A is exactly the same as angle A prime. Angle B, exactly the same as B prime. And C prime is exactly the same as C. And so dilations do not change the angle measure. Angle, distance. Angles are preserved, whereas distance is not preserved. Okay, question 17. Okay, Steve drew lines, segments ABCD and EFG and BF and CF as shown below. And then it says that this is a scalene triangle. Which statement will allow Steve to prove that ABCD, which is the one at the top, is parallel to EFG? So we want to be able to prove this. Now, how could we possibly prove this? Let's think. So we can prove lines parallel if we know things like alternate interior angles. If they are congruent, then that's proved that those two lines are parallel. If we can prove that corresponding angles in parallel lines cut by a transverse. So if we can prove those are congruent, then we also know that the lines are parallel. So let's go through this. The first case, CFG, C to F to G. If we can prove, if we know that this angle is congruent to FCB, F to C to B, well, if we know that CFG, this angle here, is congruent to FCB, that's it. That's our alternate interior angles. And therefore, we know that alternate interior angles are congruent, then that's enough to prove these two lines are similar. Let's just check the cases of the other ones. I'm going to do this in red. So the next one says that ABF, so A to B to F, I'm going to put a little dot there, is congruent to BFC, B to F to C. Well, that's here. It's not quite alternate interior because it's missing out this full distance, this full angle. It's only getting a piece of it. So that's why it can't be 2. Number 3 says EFB, so E to F to B. So I'm going to put a little star here, is congruent to CFB, C to F to B. So that's now talking about here. Well, those are adjacent angles, but they don't have to be congruent. And it's not talking about any angle touching the top line, so that's not true. And then finally C to B to F, so C, B, F, which is, we just put a plus right up there, is congruent to GFC, G to F to C, which is right here. And those two don't have a relationship that proves that these lines are in fact parallel. So alternate interior angles was the way to go, and so option 1 is our answer. Okay, so question number 18 is saying that CD, line segment CD, which is right here, it's saying that this is the image of AB after a dilation of scale factor K with center E. So this longer line segment A to B becomes a shorter one, C to D. So already we know that the scale factor K is in fact less than 1. And also it has to be greater than 0. So K is somewhere between 0 and it's less than 1. So let's keep that in mind. Now, originally A was 5 over and 5 down. So let's picture this. I'm going to change this color to pink. Let's grab a straight line. If we draw a line here, we know that A was originally 1, 2, 3, 4, 5 diagonal boxes away. And instead of it staying at 5 boxes away, 5 diagonals, it went to 2 diagonals. So when we look at that, it went from a total distance of EA, that was the full distance away, EA, and it became distance EC away. So it says which ratio is equal to the scale factor K. So K would have to equal the part to the whole that it became. So it became EC as a fraction of the whole, which is EA. And so our answer is number 1. And to compare them with some of the others, BA, which is the length of this, all over EA, well, that's not even questioning segment DC. It's not even comparing it at all. So it's not number 2. Number 3 is E to A over B to A. Again, it's not even thinking about segment DC. And number 4, E to A over E to C is almost there, except EA is greater than EC. So if EA is greater than EC, this one is going to give us a K value that is greater than 1, which is not what happened here. So for question 18, option 1 is the answer. Okay, number 19. Okay, a gallon of paint will cover approximately 450 square feet. So I'm going to stop and take that information. So 1 gallon is enough to cover 450 feet squared. An artist wants to paint the outside surfaces of a cube measuring 12 feet on each edge. So I'm going to quickly sketch that. So 12, 12, 12, they want to paint this. Now, they talk about painting the outside of this. So we're not filling this up. This is not a volume question. This is a surface area question. So each side of the shape has an area of 12 by 12. So remember, the surface area equals the area of one of these sides, which is length times width, or in this case with a cube is side times side. So that's going to be 144. And then because there's 6 sides, we're going to take the 144 and multiply by 6. So the actual equation is 6s squared. So again, that's going to be 6 times by s squared, which is 6 times 144. And that gives us 864. Now that's the surface area, so that's feet squared. Now, if we remember this information up at the top, that 1 gallon can cover 450, so therefore 2 gallons, that can cover 900 feet squared, which would be enough, whereas 1 gallon wouldn't be enough. So therefore, what is the least number of gallons of paint he must buy to paint the cube? So if he buys 2 gallons, that's good enough. That's going to get the job done. So that was the answer to number 19. Alrighty. Question number 20. In circle O shown below, the diameter AC is drawn perpendicular to CD at point C. So that's a radius to a tangent is 90 degrees. It says chords AB, BC, AE, and CE are drawn. Which statement is not always true? So keep that in mind. It's looking for a statement that's not true. Well, before I do anything else, if I just look around this diagram, I know that this is a radius and this is a radius, so they're congruent. I know that this is a diameter in the middle, and ABC is an inscribed angle, and so an inscribed angle from the end points of a diameter give us a 90 degree angle. Now AEC is the same. It's an inscribed angle coming from the end points A and C of the diameter. So this is also a 90 degree angle. So let's keep reading. Which statement is not always true? ACB, so let's change the color. A to C to B, which is right here, and BCD, B to C to D, B to C to D. It's saying are congruent. Well, I don't believe that's always true. Why should these be the same? And they would both have to be 45 degrees, but if you move B just a little over and put it here, then that would mean that this is still 90 degrees, but this angle got smaller. So therefore our answer has to be number 1. But we can try out a few of the others. And so if option 1 is the correct answer, then the others that we try should really come back incorrect. they should actually come back correct, because the question is saying which statement is not always true, and we think that we found the correct answer with option 1. So let's try some of the others. So A, B, C, so A to B to C, which is this angle right here, is congruent to ACD. ACD, well, yep, ACD is 90 and ABC is 90. So this is true. Let me put a T there. Now, number 3, BAC, B to A to C, B to A to C, this angle right here is congruent to DCB. Let's take a look. D to C to B. So that's right here. So let's think about this. Why would they be the same? Okay, well, let's look at this. This is a little hard to see, right? But we know that this is 90. And D comes over here. This is B. This is A. And this is C. So because we know these two are 90, we know they're complementary. So let's just say that this was 60 degrees. Now if this is 60, then this one would have to be 30 to make 180 in this triangle, and if this is 30, then this one would have to be 60. So therefore it is true that B to A to C is always the same as D to C to B. This angle has to equal this one, and it's because of the fact that angle A here and also angle BCA here are complementary, and angle A is complementary to the same angle that angle DCB is complementary to. So angles complementary to the same angle must be congruent. So therefore it's a little hard to see, but this one is true. Now number 4 is saying that CBA, C to B to A, which is right here, do a bigger orange dot, is congruent to AEC, A to E to C, so that's right here. And of course we know that they're both 90 degrees, so this is in fact true. So we were correct with our first thought. Number 1 is the answer because it's not always true. Okay, question 21. So in the diagram below, triangle ABC is similar to triangle DEC. So A to B to C. So notice how A and B come first, and also D and E. So these are not congruent. I was about to label this as congruent, but it's not congruent. It's just that this matches with this one. So they are not congruent, but they match. And BC, B to C, matches with E to C. So again, not congruent, but they match each other. And then the third side would have to match as well. Now, one thing, because B is in the middle and E is in the middle, now although that they're similar triangles have congruent angles. And so the order of these letters are also really important. So B and E are congruent. B and E are congruent. And also A and D. A and D are congruent. And then C and C are congruent. So this angle here, 1, 2, 3, is congruent to this 1, 2, 3. So that's also really, really important. Okay, let me remove all these signs here. All right. So now that we've labeled that, it says if AC is 12, A to C is 12, DC is 7. Well, we know that those are matching, right? Because this has got 1 arc to 3 arcs, 1 arc to 3 arcs. So 12 corresponds with the 7. Now we're also told DE is 5. And the perimeter of ABC, is 30. What is the perimeter of DEC? Wow. Now, because we're dealing with distances, even the perimeter number is a distance. This 12 that matches with the 7 is a ratio that can help us get the scale factor. So how 12 becomes 7 is the same scale factor that the 30 becomes the x, or whatever we want to call it. So 12 over 7 equals 30 all over x. We can still use this perimeter in the proportion. We don't just have to use side lengths. So therefore, let's just figure this out. If we cross multiply, we end up with 12x equals 7 times 30 is 210. Divide both by 12. So we end up with x equals 210 divided by 12, which is 17.5. 17.5, and that's the perimeter of DEC, 17.5. Number 4. All right, question number 22. And it says it's transformed by a dilation centered at the origin. So we could make this y equals, by dividing both sides by 3, we'd get y equals negative 2 over 3x plus 8 over 3. So we know it's got a negative slope. So I'm just very quickly sketching this. It looks like this line will be something like this. So basically, if this is dilated with a scale factor of, let's just make it up 3, it means that this distance here, because it's centered at the origin, that distance there becomes 3 times as long. So it goes to here, and this distance here becomes 3 times as long. So what effectively happens is that we end up with parallel lines. So that's the key for this question, is that after we take our 3y equals negative 2x plus 8, and we get it in y equals mx plus b form, so we divide by 3 and divide by 3. This is what we did right up here in orange, where we get y equals negative 2 all over 3x plus 8 over 3. And now we've got the slope to be 2 over 3, negative 2 over 3. We're looking for one of these equations that has the same slope. So in the first case, if we rearrange this, we end up, if we subtract 2x from both sides, we end up with 3y equals negative 2x plus 5. And then by dividing by 3, you end up with a slope of negative 2 over 3, which is the same. So therefore, number 1 would be our answer. Now, we could go through some of the others. So let me bring number 2 down here. If we subtract 2x from both sides, we end up with negative 3y equals negative 2x plus 5. And then by dividing by negative 3, divide by negative 3, we end up with y equals 2 all over 3x minus 5 over 3. So that's not the right answer because it has a slope of 2 over 3. And then if we try 3 by subtracting the 3x first, we end up with 2y equals negative 3x plus 5. So divide everything by 2. We end up with y equals negative 3 over 2 x plus 5 over 2, which is almost the same, except we need it to be negative 2 on top and 3 on the bottom. So it's not 3. And then with 4, if I bring 4 down here, by minusing 3x, we end up with negative 2y equals negative 3x plus 5. By dividing by negative 2, we end up with y equals 3 all over 2 x minus 5 over 2. So again, the slope is different. So that confirms our answer is number 1 for question 22. Okay, question number 23 is saying that a circle with radius 5 was divided into 24 congruent sectors. So in fact, this distance here is the radius, so that's 5. So that 5 stays all the way. This is 5, and this is 5. It's always 5. And it says, the question to the nearest integer, the value of x is, well, x is all of these curve pieces, which is a part of the circumference. Now, if it was talking about both sides, then that would be the full circumference, everything. And that would be c equals 2 pi r, which is 2 times pi times 5, which is 10 pi, which results in 31.415926, and the number goes on. But it's not talking about the entire, circumference. As you can see, this comes from, the x comes from half of this circle. So what I've got to do with this number is divide it all by 2. And when I do this on my calculator to be very, very accurate, I get an answer that x equals 15.7 and change after that, but they want the nearest integer, so I'm going to cut it here. So our answer is 16. 16 is the answer for question number 23. It says, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Well, let's take a look at the congruency postulates. If we know 3 sides are congruent, or 2 sides and included angle are congruent, or an included side and 2 angles are congruent, or even angle side, a non-included side and 2 angles are congruent, or hypotenuse leg, then we know the triangles are congruent. Likewise, for similarity, if we know 2 angles, then we in fact know the third angle must be the same. So therefore we know the 2 triangles would be similar. Also, side angle side for similarity. Now this is different to the side angle side over here, because SAS for similarity means that the sides are proportional, but the angle that is included must be congruent. And also side for similarity means the 3 sides are proportional but not necessarily congruent for the 2 triangles to be similar. Okay, so let's go through these. Option 1 says that AB is equal to DE and BC is equal to EF. Well, that's just 2 sides, and that's not enough to prove anything. The next one, D and A, B and E and C and F, well, that would prove that they are similar, but that's not enough to prove that they're congruent. So remember, angle is a postulate for similarity. Number 3, there is a sequence of rigid motions that maps AB. So AB would be like this segment here, that maps AB onto DE, so it'd be here, and also that maps BC onto EF, so BC is here, onto EF, and finally that maps AC on to DF. Well, if that was the case, that by rigid motions we can map each of these line segments onto the equivalent line segments, then that would be enough to prove that these are congruent. So through transformations, not just postulates, we can also prove congruency, and that would be option 3. That would be sufficient evidence. Just to rule out 4, let's take a look. There is a sequence of rigid motions that maps point A onto D. So that would be A onto D, AB onto DE, so that would be this blue onto this blue, and then angle B onto angle E, angle B onto angle E. Well, that doesn't prove anything about the lengths of DF and EF compared with AC and CB, and in fact we could just move this and move this, and these other rules would still be true, yet these shapes wouldn't be congruent because I could have just moved those 2 points around. So therefore 4 is not the answer, and 3 is. Okay, so question number 25 is asking us to use a compass and complete a construction. So this is a little hard to show on the screen, but I'm going to make a series of marks across this circle. So keep in mind that when I describe where to put the point of the compass, that's the sharp edge, and then where to rest the compass so the pencil touches the page, I'll try and explain how to make these marks. So we're using a compass, and we're also using a straight edge to construct an inscribed square. So in a nutshell, an inscribed square will end up with a square inside. But we can't just doodle this, we can't just guesstimate where it goes. We have to be very precise using these tools. So one of the methods to do this is to understand what is a square. So a square has 4 congruent sides, but we can't just use a ruler and measure this because it could end up not having 90-degree angles in the corners, and then it would be a rhombus. But we need a perfect square. So for this question, the key to solving everything is to understand that the diagonals are in fact perpendicular bisectors. So we're going to use this fact in green to be able to construct this. So the first step to make a square is to draw a diameter through the point. So this can start on any piece of the circle. Just make sure it goes through the center and then go to the other side. This is one of these diagonals. So now we need the other diagonal, and so we've already got one of them. We need the other one at 90 degrees. So what we're going to do is I'm going to change colors right now. I'm going to change to a red dot for where we have to put the compass point. So I'm going to put the compass point here, and then in orange I'm going to open up the compass to just more than halfway. So the point of the compass is on the red, and I open it up so the pencil is just beyond halfway. And then I kind of draw as carefully as possible an arc that is facing this point, the red dot. And then I come to the other side, and I keep the compass open the same amount, but I put the point of the compass on the other end of that diameter, the other end of that green line. And then I open up, I keep the compass the same distance as it was before, which is going to be just more than halfway, and I'm going to draw another arc going this way. So we're almost done bisecting this. So what we have to do now is draw a line through the intersections all the way to the other side. And if you do this for real with a compass, it's going to be a lot more accurate. But what we've just constructed are the 2 diagonals. So at this very moment, the only thing that we now need to do is join up all of those diagonals. So we're going to go from here to here. We're going to go from here to here. And then we're going to go from here to here, which is the 3rd side, and then from here to here. And even though this is a little twisted, that is a perfect square. And the key piece of this was all down to the fact that these diagonals bisect each other. So we don't need to put this here, but this would be 90 degrees in the middle. And it does tell us to leave all construction marks, so we definitely don't want to get rid of these orange marks or anything else. So that is precisely what we need to leave for question number 25. Okay, this is 26. Now in this question, one thing that we've got to seriously remember by the end is that it asks us to explain something. So we're going to have to use our words. We're going to have to explain. Another key phrase, word that we need to look out for is justify. If ever we're asked to justify something, then we have to use a paragraph of text, a couple of sentences to explain something. So anyways, we're told the diagram below shows parallelogram LMNO. So I'm going to stop reading at this point, and I'm going to label everything I know about parallelograms. I know this side must be congruent to this side. I know this must be congruent to this side. And also I know that opposite sides are also parallel. So I'm going to label all of this stuff. I also know in a parallelogram that opposite angles are in fact congruent. So this would be 118. And while I change color, I also know, because the top and the bottom are parallel, that LN is almost like a transversal. So 22 is the alternate interior angle to this angle, which is also 22 degrees. Not 122, but 22. So at this point, let me keep reading. It says the diagonal is LN, and the measure of angle M is 118. So this is already labeled. And the measure of angle LNO, L to N to O, is 22, which is already labeled. So it says explain why. Now I'm going to change color for this. It says explain why the measure of NLO is 40. So N to L to O, this is the angle in the middle. It's talking about this one. It wants to explain why this is 40. Well, I'm going to label it X and try and prove that it's 40. And if you look very carefully at this point, this here, I'm tracing it right now. This is a triangle, and we have two of the three angles. So we know that X plus 118 plus 22, three angles in a triangle, must equal 180. So as we begin to solve this, we get X plus, now 118 plus 22 is going to be 140, and that equals 180. So if we minus the 140, we end up with X equals 40, which is what we wanted to prove. Now, a lot of people at this point might just keep moving on to the next question, but you're going to lose credit because it does, again, say this word explain. So after you've done this work, you just got to do a simple explanation. So you can say that the measure of angle NLO is 40 degrees because the measure of angle LON equals 118 degrees because it's congruent to the opposite angle as it is a parallelogram. We could also say that the sum of angles in a triangle must be 180 degrees, and two of the angles are 118 degrees and 22 degrees, so the third must be 40 degrees. And the work for this is right here, but we have a full explanation, and so that's our complete answer for number 26. Okay, question number 27 says the coordinates of the endpoints of A, B are, and then we're given a couple of coordinates. So I'm going to plot these right now. -6 is right here, and then -5. So 1, 2, 3, 4, 5. So that's right here. This is A, which is -6, -5, and B is at 4, 0. So 1, 2, 3, 4, 4 zeros here, 4, 0. So let's just connect them because we're told it is a line segment. Just going to get a straight line. All right. So now the question asks us, point P is somewhere on AB. So P is somewhere on this line segment. And it says determine and state the coordinates of point P such that AP to PB is 2 to 3. All right, so we've got A, and then B, and P is somewhere in between them. Now the ratio of these parts are 2 to 3. So therefore P is going to be a little closer to the A side because this ratio is AP to PB and it's a little closer. So therefore P has to be slightly closer to A. Now whenever you get these in the Regents, you might be told that the use of the set of axes is optional, but it's very helpful. The next thing, whenever you deal with ratios, usually you have to figure out what is the total number of parts. So when you add these two, you see that we're dealing with 5 parts. Next, it is going to be no coincidence that you can take this line and you can split it up into 5 steps. And they do this so that it makes it a little easier for you, and that we end up with point P being exactly on the grid where the horizontal and vertical lines meet. Because the worst thing would be for us to end up with some kind of a decimal and not really knowing where it goes. So whenever you get these questions, add up the 2 parts, and then you see that we get a total of 5 parts, and then try and break this distance, this journey from A to B, into 5 steps. So this is what I mean. That's 1 step, 2 steps, 3 steps, 4 steps, 5 steps. And you'll see that I made these steps so you could even see little right triangles here. And every single step or right triangle is exactly the same. And so you'll see that this is like 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. So I've split this entire distance from A to B into 5 parts. And so the ratio being 2 to 3 means we take our 5 parts and we go 2 parts away from A and then 3 parts away from B. So that must be point P. And so the coordinates of this is -2, -3. And so that is our answer. So point P is -2, -3. Another way you could do this is you could make a triangle here, and you could obviously see it's a right triangle. Now the distance up and down on this leg of the right triangle is 5, and the distance across here from -6 all the way to 4 is 10. And again, it's no coincidence that the 5 and the 10 are multiples of the total number of parts. And you could then split this horizontal distance into a ratio of 2 to 3 and split this vertical distance into a ratio of 2 to 3. And then where these meet, that would end up also giving you your answer. So that was question number 27. Okay, question 28. So diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.75, which is labeled, and then also the 4.5 feet is labeled. It says determine and state to the nearest degree. Well, this is italicized. I'm going to circle it because it's very, very important. If we don't do this, we're going to lose a point, and it's unnecessary. So it says determine and state to the nearest degree the angle of elevation formed by the ramp and the ground. So the angle of elevation is going to be right here. So we can call this x. So keep in mind, this is the angle of elevation, which in fact is the same angle as the angle of depression, which would be coming down here. If I just draw this a little clearer, the angle of depression would be the angle from a horizontal line. So if this is our line, the angle of depression would be this angle right here coming down. That would be the angle of depression. And as you see that this is parallel to this, and this is like a transversal, the angle of depression is the same as the angle of elevation. Anyways, that was just a little bit of extra information. We didn't really need to talk about the angle of depression, just the angle of elevation. So in our picture, we have x being this angle here, and then if I change color, it makes it a little clearer. This 4.5 is opposite the x, and this 11.75 is the hypotenuse because it's opposite the 90 degrees. So TOA. So in this case, with the opposite and the hypotenuse, we're dealing with so, because it has the O and the H. The S stands for sine, so we do sine of the angle, which is x, equals the opposite, which is 4.5, all over the hypotenuse, which is 11.75. Now, to find the angle when it's trapped with the sine, what we do is we trade them. We trade the x for the fraction, so 4.5 all over 11.75. We keep the sine, but this time we do the inverse sine. And so now this is what we have to put in our calculator. And in order to do this, we do second function, sine, and then it already opens up the first parenthesis. So now we can do 4.5 divide 11.75, close up the parentheses and press enter. And we get an answer for x of 22. Now it says the nearest degree. Now on my calculator it says 22.5183, and this number goes on. So to the nearest degree we must say that x equals 23 degrees, and that would be our answer because this is the nearest degree. So that's our answer to question number 28. Okay, 29. Okay, so this looks like we've got a circle sector shaded right here, and in fact it says the area of the shaded sector is 12 pi inches, so I'm going to write that in there, 12 pi inches squared rather, and it says the length of OA is 6. Now this is a radius, this is a radius, so that's also 6. And it says determine and state the measure of angle AOC. So A to O to C is here. They want to know this angle. Let's call it X. So basically, the part of the area part that we have is 12 pi. If we were to find the whole area of the circle, we would do pi r squared, which in this case is pi 6 squared, which is 36 pi. So the fraction of this circle that's shaded is the part, which is 12 pi, that's the part, all over the whole, which is 36 pi. So if you look at this, maybe you're seeing that we can cancel some things. We can cancel the pi's now, so we end up with 12 over 36, and if you divide both by 12, you end up with 1 over 3. So the fraction of the circle that's shaded is 1/3. So if we need this angle, angle X is 1/3 of the total number of degrees available. So it's 1/3 times 360 degrees, because that's how many are available. So that equals 120 degrees. So we should go back, check the question, make sure we always refer back to what's being asked. And if it asks us for the measure of angle AOC, we should put that back and then put 120 degrees. And if you ever do a bubble that's way too big, just do a smaller one for degrees. We've got to be very, very careful. We don't want them to think that we're putting 1,200. That's our answer for number 29. Okay, question 30. Again, this is asking us to explain something here. So it says, after a reflection over a line, so let this be the line. It says triangle A prime, B prime, C prime. So maybe this is the new triangle. A prime, B prime, C prime is the image of triangle ABC. Okay, so if this is A prime, then this would have to be A, the closest points to the line of symmetry. This would have to be C, and this would have to be B. So it says, explain why triangle ABC is congruent to triangle A prime, B prime, C prime. So I've done this little sketch, but really we didn't have to do that. That's just for me to try and understand this problem, what's being asked. So the key thing is to explain why the triangle ABC is congruent. Why are they congruent? So this is all to do with the type of transformation that's being done. So the transformation, this is my answer to explain. The transformation was a reflection over a line, because a reflection is a rigid motion. This is really important that you understand what a rigid motion is. The only transformation that's not a rigid motion is a dilation, which stretches or shrinks the shape. But all of the rigid motions preserve distance. So that's what we need to put here. Now, one other thing before I put that is, I'm going to say, because a reflection is a rigid motion, and that's also known as an isometry. So these are really good words to remember. Isometry. Because a reflection is a rigid motion or an isometry, it preserves distance. And you could say between points. Points or vertices. But basically, these triangles are congruent by, now we might have already said enough, but I might as well do this now, by side, 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 because we know all distances were preserved. And hopefully you remember side, side, side being one of the congruency postulates. So that's probably more than enough to get the points for question number 30. Okay, this is question 31. This is a big chunk of text here. I hate it. So anyways, a flagpole. Let's draw the flagpole. And it's got to be on the ground, I guess. Casts a shadow that is 16.60 meters long. So if the sun is up here, the shadow is going to be all the way down here. Now the shadow is this long. Now when we see shadows, it's usually on a flat surface like the floor. So that's where I'm going to put the 1660. It says that Tim stands at a distance of 12.45 meters from the base of the flagpole. So if Tim is standing nearby, maybe this is Tim, and then in red, change his color up. The distance from Tim to the flagpole is, what did they say, 12.45. And again, this is meters. Now it says that Tim's shadow meets the end of the flagpole shadow, which we've kind of got like the top of his head is right where the shadow's coming down. So his shadow is also joining the floor there, as is the shadow of the flagpole. And we know that this flagpole is going to stick out of the ground at 90 degrees. And so is Tim, that he's standing up at 90 degrees. We can assume those things. So it says if Tim is 1.65 meters tall, determine and state the height of the flagpole to the nearest tenth of a meter. So I'm circling that again. I'm going to call the flagpole's height X. Now I need to get to work with this. So let's think how I can do this. So to find X, let's think. Well, these two triangles, both the big triangle, which goes all the way here, is a right triangle, and then the small triangle, which is Tim to the end. And we know that this is 1.65. We know this is X. We know this full distance is 16.6, or you could put a 0 on the end if you like. We don't know this distance here on the bottom, but we know that this angle matches this angle. Now, because of angle being the same, we know that these two shapes are similar. So, in order to find X, let's think. let's think. Well, we know that this distance, let's change color real quick. We know that this distance from here part way is, I'll show you over here, is 12.45. So the distance here to here, we could find this distance by doing 16.60 minus 12.45. So that gives us an answer of 415. So I now know that this is 415 meters. So to find x, we could now, knowing that they are similar triangles, we can make a proportion. X compares with the 6.65. So those sides are corresponding, as 16.6 or 16.60 if you want to put that 0 compares with 4.15. So we could cross multiply, but we don't need to do the 4.15 times x. All we need to do is send this up there, and we do that by timesing both sides by 6.65. So now on the calculator we can do x equals, and we just type in 16.6. So let me do this at the same time. 16.6 times by 6.65. I'm now just going to press equals to get that bit, which says 110.39. But then don't forget we have to divide by 4.15. And that gives me an answer of 26.6. So therefore x equals 26.6, and it's meters, and it does say to the nearest tenth. So that's our answer. Now I'm going to do this in blue. There is one other quick way that we might be able to do this, is if you see this, the 4.15 to 16.6, you can get there by timesing by 4. 4 4s are 16, 4.15s, 4.15s are 60. So whatever we do there, we could also do to the top here. So if you times this by 4, the 6.65, you would get the 26.6. So both of those methods work. The first one to cross multiply, although we didn't do the 415 times x, and the top one up here where it says times 4, this method is called scaling. So that's the end of part 2. Okay, so question number 32, it says in the diagram below, EF, where's EF? EF is here, it intersects AB and CD at G and H, okay, respectively. So everything here is already labeled. It says GI is drawn such that GH is here, and it says this is congruent to IH. So I just labeled everything up to here. Now, if this is true, then GHI is in fact an isosceles triangle. So opposite these two sides, these angles must be congruent as well. So I'm just labeling a couple of things that they already tell us. Next, if the measure of angle EGB, so change color, E to G to B, EGB is 50 degrees, and the measure of angle DIG, D to I to G, is 115 degrees. Explain why AB must be parallel to CD. So this is what we've got to try and explain. It's kind of a proof, but we're explaining why these two must be parallel. Well, let's think about this. So if they were parallel, we would know that this 50 here, this 50 which you see up here, would in fact correspond to this angle here. And if they're corresponding angles, then this would also have to be 50 degrees. So let's think about this for a second. I'm going to change the color. Let's make it green. But if they were parallel, this would be 50 degrees. And now these two angles here and here, this is column X. Let's think. These angles here, what would X have to be? Well, opposite the 115 on this adjacent angle, these two are a supplementary, well, they're supplementary, they're a linear pair. So we could say that 180 minus the 115 gives us an answer of 65 degrees. So therefore this has to be 65 degrees. Now because it's an isosceles triangle, this also has to be 65 degrees. And if these two are 65, let's just see what that means. 65, 65, and let's call this y. So now we can figure out what y is, because 65 plus 65, 65 plus 65 equals 130. And when you add y, that must give you 180 degrees. So subtract the 130. So now we've got y equals 50 degrees. That's what we had originally as well. So because this GHI angle is 50, and because the corresponding angle EGB is 50, that's the reason why we know these two lines are parallel, because corresponding angles with these lines and the transversal are both congruent. Now, we did a lot of work to explain it, but we should use some words as well. So we can say they are parallel because angle GIH must be 65 degrees. You could say supplementary to 115 degrees. Also, angle HGI is the same, which is 65 degrees, because triangle HGI is isosceles. ISOSCELES. Angle GHI, really the measure of, equals 50 degrees because sum of angles equals 180 degrees. And then finally, we can say that angle GHI is congruent to angle EGB. I'm going to put both 50 degrees, and as they correspond, the lines must, and really they're line segments, so the line segments must be parallel. So that's more than enough explanation, especially with this work on the side as well. So that was question number 32. All right, here is number 33. And we're asked to prove that triangle AED, so A to E to D, trying to prove that this triangle, let me go over in green, A to E to D, is congruent to C to E to B. C to E to B. So let's take a look. I'm going to show this work over here. It says prove. We don't need to do a 2-column, but I'm going to do this. This is going to be my statement. This is going to be my reason chart. Let's number the first one. So firstly, we know that this shape is a quadrilateral and it's a parallelogram. So let's put that number 1. A, B, C, D is a parallelogram. So you can use this symbol, 2 straight lines for parallel and then gram. And the reason we know this is that it was given to us. Okay, second thing. If it was a parallelogram, and you should always try and do this after you're given a statement, try and follow it up with a congruency statement that is a natural step from the given. So if I go to pink, because of what we were just told, we know parallelograms have congruent opposite sides. So we can say that AD is congruent to BC, and that's a side. And the reason is that opposite sides of a parallelogram are congruent. Some people might say definition of parallelogram or versions of what I've just said, but that's fine. Okay, so that was the second statement. So number 3, we've got one side is congruent to this side. Now let's take a look at the angles. We could say, well, this angle and this angle must be the same. So that would be because of vertical angles. So that would be true. However, if I go from this angle and this angle, I want to make sure that I don't next prove a side and end up with the donkey postulate, angle side side. So even though this is true, it might be easier to talk about this distance AE being congruent to distance EC, and also distance DE being congruent to distance EB. And you could split these up into 2 reasons, but they pretty much are the same thing. And the reason that we can say this is because the diagonals in a parallelogram bisect each other. So this gives us another side. So we're saying that this side here equals this side here, and also this side here equals this side here. So even without these 2 angles being the same, we've got that these 2 triangles are congruent by side, side, side. Now, if we did go the way to say that these angles are congruent because they're vertical, we would then need to go for another angle, like this angle here, matching this angle here, and we could say that they are congruent because they are alternate interior angles. Or this one here and this one, alternate interior angles. Anyways, I've proven it by side, 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 so we can say triangle. Now I'm just copying this precisely. Triangle AED is congruent to triangle CEB, and the reason is by side, side, side. Next, it says describe a single rigid motion. So remember, rigid motions or isometries, it's not the evil transformation, the dilation, which stretches or shrinks. It is rigid motions are rotations, reflections, and translations alone. So how can we get AED, A to E to D, onto C to E to B, C to E to B? And it wants us to describe it. And we've probably got to state a couple of criteria here. So that would be, you could rotate triangle AED about, or you could say around, but both are okay, about point E, so that point D is mapped, they're going to love this, mapped to point B, and point A is mapped to point C. And if D ends up on top of B, then naturally A is going to end up on top of C. And as you can see, for D to get there, it would actually need to be a rotation 180 degrees. So we should really have said that rotate triangle AED about point E 180 degrees. And we could say clockwise or counterclockwise. Because it's 180 degrees, it really doesn't matter which way you go. And then it says, so that point D is mapped onto point B, and point A is mapped onto point C. So that's the single rigid motion. Okay, so question number 34 is extremely wordy. This question is a situation involving a lake, a park ranger station, which is P, a lifeguard chair, which is L. We're told that these are two perpendicular segments, and the campground is 0.25 miles from the lifeguard chair, and also the straight paths from both the campground and also the first aid station to the park ranger station. Okay, so the first bit right here says if the path from the park ranger station, which is here, to the campground is 0.55 miles, which they've labeled in the diagram, determine in state to the nearest hundredth of a mile. Again, very important. Don't want to throw a point away on this. It needs the distance between the park ranger station and the lifeguard chair. So let me label that as X. Well, basically, if this is 90 degrees, this has to be 90. So we've got a right triangle. And so Pythagorean theorem will work. So a squared plus b squared equals c squared. If we plug in the x is a leg, it's not the hypotenuse. 0.55 is the hypotenuse. So x squared plus 0.25 squared must equal 0.55 squared. So if I just subtract 0.25 squared, this becomes x squared equals 0.55 squared minus 0.25 squared. So if I find the answer to the stuff on the right of the equation, let me just clear the calculator. I've got 0.55 squared minus 0.25 squared, and so that gives me an answer of 0.24. Now don't forget, that's x squared equals 0.24. So to find x, I've got to square root both. So the square root of 0.24 is an answer that goes on for quite a bit. It's x equals 0.4898489897, and this thing goes on and on and on. But it does say nearest hundredth of a mile, so I've got to chop it here, tenths, hundredths. Now this 9 that I'm about to chop off has the power to raise the score of this 8. So remember, 5 or more, raise the score. 4 or less, let it rest. So we can say that the distance between P and L, which so far we've just been calling X, PL equals 0.49 when we do it to hundredths of a mile. That's our answer. Okay, so let me write that in. That's 0.49, approximately. Now, Gerald believes that the distance, so we're on this part right now, Gerald believes that a distance from the first aid station to the campground is at least 1.5. So he thinks this entire distance here is at least, which means greater than or equal to 1.5. So if that's the case, if I subtract this distance here, 0.25, he's basically saying that he believes this distance from F to L has to be greater than or equal to 1.25. And it says, is he correct? So we've got to answer that, and then we have to justify. So let's see. In order to answer this, we need to remember that there are special proportions here. So if this is A and this is B and this is C, where A and C are kind of the projections of these legs above and B is the altitude, we can come up with this proportion. A over B equals B over C. So let's figure out, instead of calling this A or B or X, let's call it Y, because we haven't used that yet. So effectively y over 0.49 equals 0.49. Now remember, these are like rounded numbers, right? 0.49 all over 0.25. Now remember, if we do 0.49 and then and change and then square it, we're going to get back to that 0.24. We're going to get back to this up here. So when we cross multiply in this case, this times this gives you 0.24. Now we could send this up here, but we're just trying to find the y, so we could just leave it 0.25. So when you do 0.24 divided by 0.25, that gives you an answer of 0.96. So basically this distance from F to L, which we've called y, is 0.96 miles, and that's an exact number. So let me just change color and show you exactly what I mean. Over here, for Gerald to be correct, this distance y would have to be more than or equal to 1.25, and we've just discovered that that distance is this. So we must now answer Gerald is not correct, because FL equals 0.96, and I guess we could do FC equals 0.96 plus 2. Not 2.5. Let me go back a step. Gotta just hold shift and get rid of this. 0.96 plus 0.25, so 0.96. 0.96 plus 0.25. So that whole distance that we get when we calculate it is 1.21. And this is less than the 1.5 miles. And that's what he thought it was. He thought it was at least 1.5. Okay, so then that is our answer for 34. Okay, this is the last part. This is part 4. There are 2 questions here. So this is the first question, which is a 6-point question. 6 points. So it says the water tower in the picture below. The water tower in the picture below is modeled by a 2-dimensional figure beside it. So this water tower has been drawn as this flat 2D shape. It says the water tower is composed of a hemisphere, which is this half sphere. Also a cylinder and a cone. There's a cylinder in the middle and a cone up at the top. It says let C be the center of the hemisphere. So this is very, very center. And D is the base of the cone. D is the base of the cone. It says AC is 8.5, which is labeled. BF is 25. And the measure of EFD is 47. Everything is labeled so far. It says determine in state to the nearest cubic foot. Very important again. The volume of the tower. So let's get to it. Volume of tower equals volume of cone plus volume of cylinder plus volume of hemisphere. So let's work out each of these. The volume of the cone is going to equal 1/3 base area times height. The volume of the cylinder is going to equal base area times height. The volume of the hemisphere is going to equal, well, if it was a whole sphere, it would be 4/3 pi r cubed. But because it's half a sphere, we're going to times it by 1/2. And then over here, for the cylinder, it's pi r squared h. And for the cylinder, this is also going to be 8.5. And up here, for the cone, this is going to be 8.5. So the cone is going to be 1/3 pi r squared times h. And we're going to basically add all of these together. If we multiply these fractions, we get 4/6 pi r cubed. Now, we could almost type all of this into the calculator. We know that R equals 8.5. So every place that is an R, we're going to just plug in the 8.5. But there's one thing that's slightly tricky here, and that is this height. Let me just change the color of this pen. That is this height right here. We do not see this in our diagram, and you might think, well, the height of the cone isn't that just 8.5, but it doesn't have to be. It can be a little more, it could be a little less. So let's call this H and think, how do we find that H? Well, we know that this is 8.5. We know that this is a right triangle. We know this is 47 degrees. So we should be thinking so ka toa, and the 47 to the opposite is the H, and then to the 8.5 is the adjacent. So we're dealing with tan. So over here I'm going to say tan of 47 equals opposite, which is H all over the adjacent, which is 8.5. So we could say that H equals, when we times both by 8.5, it's gone. 8.5, H equals 8.5 tan 47. So at this point, I'm not even going to work this out. I'm just going to write everything as in one shot. So the volume of this tower equals 1/3 pi times by 8.5 squared times by 8.5 tan 47 plus, now we're doing this bit right here, pi 8.5 squared. Now this time, this height is the height of the cylinder which we have, which is 25 plus, now we're doing this bit here, 4/6, which is really 2/3, pi times 8.5 cubed. So you could work out each of these pieces separately on your calculator and add them together. I'm going to try and one-shot this whole thing and then come back with the answer. I just have to type in all of that into my calculator. I get an answer of 7650.373, and this number goes on, but because it says to the nearest cubic foot, we need to leave our answer 7650 feet cubed. This is our answer to the nearest cubic foot. Next, so this is the second part of this question. So we've got to make sure we don't skip big parts like this. And change the pen color to blue. So it says the water tower was constructed to hold a maximum, so it seems like it's important, maximum of 400,000 pounds of water. If water weighs this much per cubic foot, so if water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? And then justify your answer. So we can't skip any part of this. So right now we got the total volume, the total capacity is 7650. So it says if it's filled to 85%, so 85% of this is going to be 7650 times by 0.85. So let's just do that really quick. Times, so I'm taking the answer that I had on my calculator with the 0.3733 and so on. I'm going to times it by 0.85. So that gives me an answer of 85% being 6502, and then it's like 0.8 and change, so that's 85%. Now if that's the volume at 85% and it weighs this much per foot cube, we've got to take the volume at 85% and multiply it by that. So I'm going to do my answer of the 6502.8 plus change times by the 62.4 pounds.
62.4. And so that gets an answer of the weight of this water. When it's 85%, the weight of this water is going to be 405,775.8 and then change. Now if you look at this number with the comma, we've got to think, is this more than the weight limit? And remember, it cannot exceed the weight limit. So we've got to look back and think, what was the weight limit? Well, there it is, it's 4,000 pounds. So this is above the weight limit. So we've got to answer the question, can the water tower be filled to 85% without exceeding the weight limit? So the answer is no. If it is filled to 85%, the weight is 405,775.8 pounds, which exceeds the limit. So right here we answered their question, can the water tower be filled? And we also justified the answer. We've explained that it's more than the limit. And then we also have this work if that is needed to get us some more points as well. So that's question number 35. Okay, 36. This is the last question from this test. All right, question number 36. In coordinate plane, the vertices RST, R is 6, -1. So I'm going to go there 3, 4, 5, 6. 6, -1. So this is where R is. S is at 1, -4. 1, -4. S and T is at -5. 1, 2, 3, 4, 5. -5, 6. 3, 4, 5, 6. Now let me join these up. I'm going to use something a little lighter. So I'm just joining up all these points. All right, great. So we're told in the coordinate plane, the vertices of RST are those. Prove that this is a right triangle. Well, looking at it, to prove that this is a right triangle, looks like we pretty much need to compare the slopes of ST and SR. So let's take a look. The slope of ST. Well, slope is rise over run. So let's see how much it rose from S to T. Well, in fact, it looks like it goes down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It dropped 10, so the rise is -10 all over the run, which T is right here, and it goes 1, 2, 3, 4, 5, 6. So the slope of ST, if we simplify this fraction, becomes -5/3, just by dividing by 2, dividing by 2. Now the slope of SR, let's take a look at this. The rise looks like it goes up 3, and the run looks like it goes across 1, 2, 3, 4, 5. So it rises 3 and it goes across 5. So if these were the same slopes, then these two lines would be parallel. But if these two lines, segments, are perpendicular, then perpendicular lines have the negative reciprocal slope. So something that's m becomes -1/m. So in this case, let's take a look. 3/5, the reciprocal is 5/3, and negate it. So that's exactly the situation that we've got. So therefore, ST is perpendicular to SR. So the measure of angle TSR equals 90 degrees. Therefore, triangle RST is a right triangle. And we just proved it. Okay, next it says state the coordinates of point P such that quadrilateral RSTP, so R to S to T to P, so P is going to be somewhere, let's do this very faintly, P has to be somewhere over here, something that's going to make this into a rectangle. So how can we do this? Well, I'm going to go to this very, very light blue pen and watch what happened. So it wants us to state those coordinates. So from S to R, we went over 5 and we went up 3. And so to keep this same slope over here, to keep the same slope, they would have to be parallel. They need to have the same slope. So we can do the same again, go over 5 and up 3. So 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So this becomes a point. If you don't see it, I went over 5, I went up 3. So this is where point P would be. And if you look carefully, this is a 0, comma, now we're 3 above where 6 was, so it's 0, 9. And if I finish off the rest of my rectangle, I'm going to use orange for this. This basically comes here, and then P joins up with R. So this is going to be 90 degrees, because this is a parallel line to the one at the bottom. And so this here, RSTP, is a rectangle. So I know I've got everything on my diagram, but I should write it. P is 0, 9. And my work's up there. Okay, the final part of question 36, and indeed the final part of this test, is asking us to prove that this quadrilateral RSTP is a rectangle. So we can do a 2-column proof. You can do a flow diagram proof. You can do a paragraph proof. So there's different ways to prove this. It's kind of nice that they're not making you do just one particular type of proof. So let's think what a rectangle is. A rectangle is almost like a parallelogram. The only difference is that there's a 90-degree angle, which if everything is parallel and this is 90 degrees, all other angles must be 90 degrees. So therefore, this particular parallelogram would be a rectangle. So the first thing that we can do is talk about the slopes so that we can prove that we have parallel sides, 2 pairs. So we can say the slope M of PT equals, so our rise here was 3 and our run was 5. So 3 over 5. The slope of SR again is 3 up and it was 5 across. So 3 over 5. So we can say therefore PT is parallel to SR. Next, look at the slope TS. So that's the slope of TS. So as we counted before, we went down from 6 to -4. So we went down 10. And then we went across 1, 2, 3, 4, 5, 6. We went across 6. So this simplifies to -5 over 3. And the slope of PR equals, and we could count it, we go down from 9 all the way down to -1. So that's a rise of -10. And then we go across from 0 all the way 1, 2, 3, 4, 5, 6. We go across to 6, which does in fact equal the same, -5 over 3. So we can then say that TS is parallel to PR. So we now know that we have 2 pairs of parallel sides. So we know that PT is parallel to SR and TS segment is parallel to PR segment. But next, we also know that TS is perpendicular to SR because they have the negative reciprocal slope. And that's how we know that the measure of angle TSR equals 90 degrees. And a parallelogram with a 90-degree angle is a rectangle. And without this last statement, parallelogram with a 90-degree angle is a rectangle, we would in fact lose a point. So we have just proven that quadrilateral RSTP is a rectangle. And so we just proved it using a type of paragraph proof with other reasoning and some number work as well in there. So that concludes this test.